Okay, on 4-6, do you have that sheet? Yeah.
Negative.
On 4-6? Not objecting?
Oh, no, sorry, not the.
Okay. You're talking about 6-1?
Yeah.
Yeah, okay, sure. So what I want to look at is number 12. I think maybe that the first part, I'm assuming, unless you have questions on problems before 12, I'm going to look at 12. And the two lines that are given to you is y equals minus 2x plus 2/3. And then the other one is y equals minus 2x plus 3. And notice the question is, are those parallel? So tell me, what would you do with this to answer that question?
Yes, you look at this slope, they have the same slope. And
So-
they have,
So Gabe says yes, everyone agreed that it is the same. And Gabe says because why?
because they have the same slope.
Okay, and the slope is here, right?
Here, yes.
And here. So M1 equals M2 is equal to minus 2, right? Okay, then the next one, I don't know whether I did these in class or not, but I just was looking at this morning and thought I would go over them. 14, and the two lines are y equals 1/2 x plus 3/2, and the other one is y equals negative 1/2 x plus 3/2. And the question is, are they perpendicular?
Nope.
Okay, everyone say no? Okay, so that would be the correct answer, no. And the reason is, you look at the slopes again, right? And the slope M1 is equal to 1/2, and the slope M2 is equal to a negative 1/2. And to be perpendicular, what must be the relationship between M1 and
Yeah.
M2?
You have to be the reciprocal.
Okay, it's got to be reciprocal, so it's anything else,
Yes.
it's got to be a negative, right? So you see M2 is a negative, it meets that qualification, but it's not 1/2 reciprocal. Right? The next one that I wanted to look at is 18. And it says the lines 4x minus 3y equals 2 and 4x plus 3y equals minus 7. And the question is, are the lines perpendicular? And so in order to do this, we're going to have to do know what? Okay. We're going to have to know the slopes. And so Mildred is saying that probably what you should do is put both of them in this form. Correct? If you recall, when we get done, there is kind of a short way that you can find the slope. But I will take each one of those and put it in that form. So let's look at the first equation right here, 4x minus 3y equals 2. And how are we going to proceed to get it in this form? What's the first thing that you want to do? Okay, Mildred is suggesting taking the 4x and putting it over there. Is that what you're suggesting? Bill? So, and that's what, you know, there are many ways that you could do this. This would be one. Is everyone good with that? Mildred just wanted to take that 4x, put it over on the other side. Now then, what would be the next thing you want to do? What's that? Y by itself. And so, I'm trying to think. Kate, okay. I'm trying to get there. So Kate, what would you do to get Y by itself?
Divide by -3.
Okay, Kate says divide everything by -3. Same thing as taking -1/3 times it. So. Now, if any of you do not understand any of the steps, be sure and ask. Gabe can't see because he's got his clearance. Okay. So we've gotten Y by itself right here. And what do we got here? Minus 4x over minus 3 is it's 4/3, positive, right? So it's 4/3 x and negative 2/3, right? Now, in order to analyze the problem we're doing, which is the important thing?
4/3.
That 4/3, right? Because that's the slope. That's the important thing. Now, this equation, to get it in line as our next question, what would you do first? I'm trying to, who said it? Okay, subtract the 4x from both sides. So we would have 3y equals a negative 4x minus 7. Did I do it right? That's right, isn't it? Okay, so now what? Okay, divide every term by 3. Now, what's my, on the left-hand side, I have what? Y equals negative 4/3 x minus, is that 7? Okay, and then divide by positive 3. Okay. So the values that are important, we said this was important, and the value over in this one is which one? Negative 4/3. Now, we're looking at the question that says, are those two lines perpendicular?
No.
So the answer is no. Now, I want to show you something that will help us a little later on. Notice the numerical coefficients, and I'll tell you, the terminology is this. A numerical coefficient is a number that's multiplied by the variable. So the negative 3 is the numerical coefficient of y. If that's true, then what's the numerical coefficient of x in this one? 4. The 4, right? What's the numerical coefficient of x here? What's the numerical coefficient of y there? 3. Just so that you know, I have to talk terminology, so I'm going to say these words. So notice that this 4/3 is actually the numerical coefficient of the 4 in the numerator and the numerical coefficient of the 3 in the denominator, and it's going to be the opposite side of those two, because see, it's a -3. Now, take a look at this. Notice the numerator is the numerical coefficient of the 4. And the denominator is the numerical coefficient of the 3. And what do you do to find the slope? Change the sign. So this is called, these two equations are called written in standard form. And this is going to be important a little bit later on in this section to analyze problems. Standard form is any time you write it as ax plus by equals c. Slope-intercept form is any time you write it this way. So if you see it written in standard form, and it's like this, what would be the slope, what would be the numerical coefficients you pick, and where would you put them if you saw something in standard form? The slope of that line. From what we just talked about. What did we say? The 4 was the numerical coefficient of the x, and the 3 was the numerical coefficient of the y. So, if you saw this, and a and b are constants, so a is the numerical coefficient of the x, b is the numerical coefficient of the y, and c is going to be constant term, what would you say that the slope is of that line? What did we do down here? We looked at that and we said that 4 is there. It's the numerical coefficient of the x term. So what would we put in the numerator here for that equation? The a or the b? The a. See this? When we're doing slopes down here, we go back to this equation. That 4 came from the numerical coefficient of the x. That 3 came from the numerical coefficient of the y. So what are we going to put in the denominator for that equation? Say it out loud. Say it out loud.
B.
The b, right? And what do we do? What did we say that if we put 4 over -3, what do we have to do with the sign? You have to change it, right? So in any standard form equation, when it's written in standard form, it's going to be the numerical coefficient of the a over the numerical coefficient of b, changing the sign. Any questions? See that? And you see how much simpler it is, once you understand it, to go from here to this kind of thing rather than having to go through this process. Make sense? So you could write it in slope-intercept form and pick up the slope, or you could look at standard form and pick up the slope. Does that make sense? Now, turn your page over and look at 32. You see that question? It says, if the graphs A1x, that is, A1 is the numerical coefficient of x, and B1y, so B1 is the numerical coefficient of y, equals C, and A2x plus B2y equals C2 are parallel. So they're saying if they're parallel, then express A1 over B1, which is really what? The slope of the first equation, isn't it? Technically not completely because it's a minus out front, isn't that right? So they're saying if they're parallel, what has to be the relationship? What has got to be the relationship in terms of A2 and B2 if they're parallel?
It has to be the same.
Just because Gabe answered it quick, I want everyone to think about it. What would you put, where would you put A1 and where would you put A2 here? A2 and B2.
A2 would be on top and B2 would be on bottom.
Technically, it's not the slopes, but both of them would be negative to be the slopes. But, do you see that? And this is the way you look at the general form of what you're doing. You follow it? And what this is doing is it's trying to help us understand, that we can look at equations and know what they look like. And this is where we're going to go in this class, is that what we want to do, because we're learning to graph things and we're learning point slope and other things. What we would like to do is be able to look at an equation and say, this is what it graphically looks like. And this one is related to this one in a certain way. They're parallel or perpendicular. And you can do it visually by looking at it. And that's where you're trying to, you're trying to gain your knowledge and understanding to get to that point. Does that make good sense? All right. So number 22, I have 22 circled as problem view. Let's just, now I'm arbitrarily picking these out. I don't know whether you would have trouble with them, you wouldn't have trouble with them. And we're going to look at it. If the line contains, if the line contains points -1, 2, and 3, 4, is that line perpendicular to the line that contains -1, 3, and a -4, 1? What process would you think you would go through to determine whether that statement is true? Okay, just you find the slope formula and apply it to these. Now, by the way, I want to tell you this. When we take analysis, I kind of expect you to know the formulas because, as you're going from here on a weekly course, what you have to use. But when we get to an hour, this is what I'm going to want to do. I want the class to go together and figure out what kinds of formulas you want me to develop, or you can develop and I can look at it, and have you have on a sheet when you take the exam. Because I don't expect you necessarily to recall all the formulas if we cover several chapters. But I expect input from you as to what everybody's going to have to do. Does that make sense? So as we go along, I want you to be thinking about putting together a formula sheet that you think would be helpful. And then I'm gonna look at it and I'm gonna say, this is what I want to do. Is that fair enough for everybody? And you don't have to worry about remembering. You just have to remember how to use the sheet. And then what we'll do is I'll run it off, I'll hand it to you so that you, in advance, you can look at it and get yourself accustomed to using it. That sound fair enough? Because I guess I have several reasons. What I'm hoping is that you can utilize this material in your practice of everyday life. But you're going to find, I don't remember all the formulas. I have to lots of times refer back. I know what it is I'm looking for, but I have to refer back to be able to find it. So I think that's only fair for you to get used to that. So Mildred has suggested that what we have to do is use this slope scale. In each one of these scenarios, right? There was 2 points. So the first one, we have a line that contains these 2 points. And in the second case, we have a line that contains these 2 points. And we are asked if those lines are perpendicular. And Mildred has said that first of all, you've got to find the slopes, right? And then, so let's just kind of step through it, what we're thinking we've got to do. Once we find the slopes, we're going to look and see whether they're what? If they're perpendicular.
Negative inverse of each other.
Negative inverses, right? Right? So for this one, and I'll call this slope M1, what do you want to do? Call this one X2Y2. So 4 minus 2 over 3 minus -1. A minus 1. Okay, so this is 2 over 4, which is 1/2. And then we're going to do the same thing over here, right? And I'll use the right one as X2, Y2. So Y2 is going to be 1 minus 3 over minus 4 minus a minus 1. So the numerator is going to be -2. In the denominator, this is 4 plus 1, correct? So it's a minus 3. Is that right? Did I do that second one right? It's 1 minus 3 is minus 2, denominator 4 plus 1. So then this is a plus 2/3. Now the question was, are those two lines perpendicular? Okay, is no the right answer. And it's because in order for them to be perpendicular, what would have to be the relationship between M1 and M2? Okay, negative, don't forget the negative. Because they don't meet that, not perpendicular. Are they parallel?
No.
Because parallel, they would have to be equal. The next one that I'm going to look at. 26 says find the equation of the line containing the point 2 minus 5. And it's parallel to perpendicular, no, perpendicular. So I'm just going to write perpendicular to y equals 5 halves x minus 4. Now, in order to solve the problem, you've got to kind of get formulated here what you're going to do. What is it that, in order to do this problem, we're going to have to do? What do we have available to us, and what do we have to find? From what it's stated. What's that? Okay, we have, I'm going to put words in Dave's mouth. We have the point on the line, right? What we don't have for this line that passes through 2,5 is its slope. And we are able to get the slope because this information is given to us, right? It's perpendicular to this line. So what is the slope of this line? Okay, and I'm going to call this one slope M2 is 5 halves. Does everyone agree?
Yeah.
But what we need is what? The slope of this line. And I'm going to call that M1. Now, this line that has this information is perpendicular to that line. What's the relationship between perpendicular lines? Negative reciprocal. So in order to find M1, we got to go negative 1 over M2, correct? Everyone? So M2 is this, so what's it going to be? Everyone agree, negative 2/5? Now, do we have enough information to find the equation of the line that passes through this point? Yes or no? Okay, yes. And we're going to utilize what equation? Point slope? Or are we going to use slope pointers? Okay. The point slope. Does that everyone agree? And maybe what you people should do for me and for the class is work up a formula sheet for that 4. One, if somebody does formula sheets for crib sheets, you work something up and show it to me, I can use it. All right, so now that with the information that we have gleaned, what are we going to plug in for this equation? We're going to go y minus negative 5. What is it? Okay. And then we're going to plug in for this m what? Negative 2/5. And then we're going to go x minus 2. Now, this is gonna be as y, what? Plus 5 equals, and you'd have to distribute that negative 2/5 through. Right? So this is going to be a negative 2/5 what? X plus, because it's a negative, negative, plus, or would you have to go 4/5? Now, as far as answering the question, you've kind of got an answer. But sometime in the future, you're going to be wanting to put this in a calculator. And in order to put it in the calculator, you can't put it in this form. It always has to be slope intercept. So, and this will give us practice. So we have to have y by itself, and what are we going to do with that equation? Okay, subtract 5 from both sides. Now we got those two constant terms, and what are we going to do with those so we can combine them? This is sometimes where people have difficulty with this. You have to find what? Common denominator, very good. And what is the common denominator between a 4/5 and actually 5/1? What is it? 5. And that 5, then, in order to get this with a denominator 5, what do we have to do? Okay. Times 5 over 5. Okay. Now we have a denominator 5. And do you see what I wrote in red is actually, we multiplied that number by 1, right? We haven't changed the number, but we got it in the form with the denominator 5. And then it's y equals minus 2/5 x plus. And I don't know that it's plus because you see this is going to be 5 is in the denominator, right? But in the numerator we would have 4 minus 25, right? And that would be a what? Minus 21. Am I doing too much in my head? Okay, is everyone good? See, this is going to be 25, that's going to be 4, this is negative, that's plus. So I really anticipated wrongly to put a plus there. It actually is going to have to be a minus what? 21 over 5. And now let's review the question. It says, find the equation of the line containing point, this point up here, 2 minus 5, perpendicular to the line y equals 5s minus 1. Is that the equation of line? It says find the equation line containing the point 1, 3, perpendicular to 2x plus 5y equals minus 1. Now what do we need to do? What's going to be our process?
You need to take the 2x plus 5y equals negative 1 or 2, y equals 1.
Okay, we need to find the slope of this one, right? we can do y equals mx plus b, but what did we just say there's an alternative way to find the slope? Remember we spent some time with it? The slope of that line is going to be what?
2, negative
Okay, it's going to be the numerical coefficient for the x in the numerator, right? Then the numerical coefficient for y in the denominator with a negative term. Right? It really shortens up the process. Now, that's the slope of that line. What's the slope of this line? What does it say the slope M1 has to be? It's got to be what? This line's got to be what in relation to that?
The same.
Perpendicular,
Oh,
right?
so negative.
So what you have to do is do what? Negative 1 over M2, negative reciprocal. So it's going to be a negative of what? A negative 5/2, right? So I reciprocated the 5/2, but I have to carry that minus sign down, and then I got an opposite sign, correct? So M1 has got to be a positive 5/2. M2, M1, negative 6. Now, the process of finding the answer here is the same as the previous problem, correct? What's the equation we're going to plug into? I don't want to do that process. What is it? Do you remember? It's going to be point slope, which is it's point slope. Okay. Now, give it to me.
Y minus y1 equals m x minus.
Everyone agree? And then you'll put that in for x1, y1, and you'll put this in for slope. Are you good? Okay. Was this review helpful? Okay. Now, in the future, what I want to do